Hello everyone and welcome back to CodeByTushu. I hope you are having an amazing day. So make consistent progress in your coding journey. So from today onwards, all my LeetCode solution will be available completely free on my website CodeByTushu. So instead of searching through GitHub, you can simply visit my LeetCode section on my website and they access every solution along with future update. And I will also updated a decided video explaining everything very soon. So today we are back with another LeetCode daily challenge. So LeetCode 3620 network recovering pathways. So at a first glance, this problem looks like a normal graph problem, but after reading it carefully, you will realize that it combines multiple concepts together. So in this problem, we have to deal with DAG. DAG is directed align graph and online offline nodes and binary search on answer and topology processing. So without wasting any more time, let's get started. So first of all, problem understanding. We are given a directed wrangling graph, a DAG. Each edges contains a recovery cost. Some nodes may be offline. A valid path from node 0 to node n-1 must safely to condition. First, every immediate node on path must be online, and second is total recovery cost. All edges on that path must be excused k. So now come to interesting path. The score of a path A defined as a minimum edges cost present on the path or task to maximize this score. It's very simple word. We want to choose a valid path whose weakest edges is as strong as possible. So important observation. Suppose some ask you, can we build a valid path whose minimum edges cost at least 5? This question is such much easier than directly finding the maximum score. If the answer is yes, then maybe we can even achieve 6, 7 or something larger. If the answer is no, then every value greater than 5 will also fail. This increasing that decreasing behavior immediately suggests using binary search for every candidate value. We simply check whether such a path exists. If it does, we search for a longer answer. Otherwise, we search for a smaller one. So, and approach like next step approach. Our solution work in 4 major steps. Step 1: build the graph using a list. At the same time, find the maximum edges cost. This becomes the upper limit or binary search. So step 2: apply binary search on the answer. Each middle value represents the minimum edges cost we are trying to achieve. So, and step 3: ignore every edges whose cost is smaller than the current limit. Also ignore offline immediate nodes. Now progress the remaining graph using topological order. While in processing, compute the minimum recovering cost required to reach every node. And step 4, if we can reach node n-1 with a total recovery cost less than equal to k, and then the current answer is possible, otherwise it is not. So now guys, let's Java code. And first of all, class solution and function solution. But first line is we important Java's until package, because this solution uses collection like array list, query, array duke. So, and next line is store the total number of nodes. And next is create the adjust list representation of the graph, and use the for loop like every adjacency list initialization, all the lists are empty. So this variable store the largest edges cost present in the graph. So, and again use the for loop, traverse every edges one by one. So, and graph the add new list, and insert the direct edges into the adjust list here, and update counting. Then represent 3 of the smallest, largest and valid score found. Use the while loop again, like start the binary search loop. This way we will continue searching until the search space becomes empty, and calculate the middleware. Next line is and if condition, use the call the helper function. So if the answer is possible, you store it as our current best answer. So next is the try finding an even large minimum edges cost, otherwise reduce the binary search. And after binary finishing side, like ans store maximum valid path score, so we simply return it. And next is private function completely. And this explanation is not important, but simply so guys. So guys, code is complete, and save the code and submit the code, and we will wait guys. And code is right guys, and complete strict 81 days, and click the cross button, and thank you so much guys. And check the case 1, case 2, and time complexity is so important, like omega v plus e multiply log m, because binary search run for omega log m, and building the graph omega e, and each binary search process the graph once omega v plus e overall, and space complexity omega v plus e. And the biggest lesson from this problem, sometime the answer is not found directly nested, we convert the problem, this series. And I hope this step-by-step explanation helped you understand both of implementation and evaluation. And if you are enjoyed this video and like this video, comment your approach and subscribe to CodeByTushu channel. And thank you so much guys.